So you're interested in sustainable chemistry, right? Like, how are researchers making the production of everyday chemicals more eco-friendly?
Absolutely. It's a hot topic.
Well, get this. Scientists over at Yokohama National University, they might just have a game changer on their hands. We're doing a deep dive straight into their latest journal article.
Yeah, their work is really fascinating. What's so intriguing here is they found a new way to make one of these key chemical building blocks, one that's usually produced with fossil fuels. They found a way to do it using just renewable electricity.
Okay, hold on. Stop right there. Let's unpack this a bit. What exactly is this building block we're talking about? What kind of things is it used in? I mean, help me out here.
Sure. So it's a type of molecule called a cyclic amine. Basically, picture a ring of atoms, and embedded in that ring is a nitrogen atom.
Okay, with you so far?
Now, that structure, it gives the molecule amazing versatility.
Wow, I see.
One very important cyclic amine one they focused on in this research is piperidine. You'll find it in all sorts of products, medications, pesticides, even things like flavors and fragrances.
Piperidine, huh? Okay. I gotta say, the name doesn't exactly roll off the tongue, but it sounds like it's in practically everything. Kind of mind-blowing to think something like that is hidden in so many things we use every single day.
It really is.
So let's get down to the nitty-gritty. What's the traditional way of making this piperidine, and why is there a need for a new method in the first place?
Right, so the traditional process, it relies heavily on hydrogen.
Okay, and hydrogen, that seems like it could be a good thing, right? Like clean energy and all that.
Well, here's the catch. The most common way to get that hydrogen is from methane.
Ah, I see where you're going with this.
Which, as you know, is a major contributor to those pesky greenhouse gas emissions.
Not exactly aligning with our sustainability goals.
Not even close. Not very green.
So we really need to find a more, eco-friendly way to get that hydrogen, right?
Exactly. That's the crux of it.
That's where this new research comes in, yeah.
Yeah.
They found this totally new way to create it, right?
Right.
Using something called, what was it again? An AEM electrolyzer.
Yes.
Can you break that down for me? What is that exactly?
Okay, so imagine this, okay? A device, it splits water, simple H2O, splits it into its core elements, hydrogen and oxygen,
Okay.
using just electricity.
Oh, wow.
That's your AEM electrolyzer.
So just to be clear, the electricity used, it's all from, renewable sources, right?
Straight yeah.
So we're talking absolutely no fossil fuels involved at all in this entire process.
You got it. Bypasses fossil fuels entirely. It's way cleaner.
Wow, that's amazing. And they were able to, use this hydrogen to actually create the piperidine?
They did, yeah.
How efficient is this whole thing?
Well, they managed to achieve a 78% yield rate.
78%. That's amazing. For a process that's, so much greener than what we were using before, that's incredible. Were there any downsides that they found with this new method? Any catches?
Well, one challenge they did encounter was this increase in cell voltage within the electrolyzer
Okay.
over time,
Okay.
which could, potentially reduce the energy efficiency of the process down the line.
So kind of like any appliance you'd have in your house, it needs that occasional tune-up.
That's a good way to put it, yeah. They're exploring different design improvements to the AEM electrolyzer itself
Oh, interesting.
to address this voltage issue. One thing they're looking at is customizing the design of the electrolyzer specifically for this kind of green chemistry.
Oh, that's cool.
It's like you have a specific tool, right?
Yeah.
For a very specific job.
Yeah.
Instead of using a generic one.
Makes a lot of sense. Now, this research focused on piperidine, but I'm curious about, the bigger picture here.
Okay, yeah.
Could this AEM method be used, scaled up to create other chemicals, too?
Right.
Potentially making the entire industry more sustainable.
Now you're talking. That's the really exciting part, right?
Hmm.
So while the research, focused on piperidine specifically in this case,
Yeah.
this technology, it could revolutionize how we produce a whole bunch of nitrogen-containing compounds.
Wow.
It's huge. Imagine greener methods for manufacturing all sorts of things.
Okay, what? Give me some examples. Okay, give me some examples.
Well, let's take pharmaceuticals for a start.
Mm.
A lot of medications, they incorporate these kinds of nitrogen ring structures.
Oh, really?
Yeah. So being able to, synthesize them more sustainably, that could have a massive impact. Or think about agriculture. Fertilizers.
Right.
They often rely on nitrogen compounds, too. What if we could produce them using only renewable energy and water?
Okay, wow. I'm starting to see the true scope of this. It's like, it's not just one thing. It's like this chain reaction of possibility. And if
Yeah.
we can actually make those kinds of changes across all these different industries,
Yeah.
I mean, the positive impact on the environment, it could be absolutely enormous.
It's huge. And it really, it highlights the power of this kind of scientific innovation. Like it has the power to drive real change in the world. It makes
Yeah.
you wonder what other seemingly insurmountable challenges are out there that we can overcome if we just, if we apply this kind of ingenuity.
That's a fantastic question. And it's a great question to leave our listeners with, too. If we can find a greener way to create a chemical building block as widely used as piperidine, something that's in so many of the products that we use every day, what other industrial processes are ripe for this kind of reimagining? I think there's so much potential here for a more sustainable future. And it all starts with incredible research like this.